Hello, my beautiful darlings. We are on to our last set of notes for Unit 4. Excitement! Yay! We're almost done with our first unit. Look how quickly summer school goes. All right, so for this, we are doing systems of linear inequalities, which means we're graphing two or more at the same time. So the key here is solutions are points that work for both inequalities. We're going to focus on two inequalities. You could have 3, 4, 5, 6, 10 inequalities, but the key is it has to be a solution for both. So example is to check, an ordered pair just to see if it's a solution. So example 1, is the ordered pair a solution to the system of linear inequalities? So we have these two linear inequalities. So we're going to check the point -2, -1. So I plug in to the first inequality, -1 for y and -2 for x. So I get -1 is greater than 3 times -2. -1 is greater than -6. So now I plug that point into the second inequality. Make sure you plug in correctly for x and y though. The x is -2, the y is -1. So -1 is less than or equal to the opposite of -2 minus 2. So I get -1 is less than or equal to 2 minus 2. -1 is less than 0. It works in both of these. So the answer is yes, it is a solution. So B, I'm going to check the point 0, 4. So again, I plug in 4 for y and 0 for x. So I get 4 is greater than 3 times 0. Yes, 4 is greater than 0. We're off to a good start. So now I'm going to plug this into the second one. So I get 4 is less than or equal to the opposite of 0 minus 2. 4 is less than or equal to -2. No, it's not. It is not. So no, this point is not a solution. So it doesn't matter that it worked in one of them. It has to work in both of them. All right, so example 2, you are actually going to do the graphing and find all the points that are a solution. So I tried to color code it here. So the first one I did in red. So this is a horizontal line. It had an equal sign, so it is solid. If I check the point 0, 0, I get 0 is greater than or equal to -1. That is true. So I did these red arrows going up from the red line. So the second one I did in blue. So we have a slope of -3/2 and a y-intercept of 2. So there's 2. Down 3 to the right 2, or up 3 to the left 2. There was no equal sign, so notice I made it a dashed line. And again, I decided to check the point 0, 0. So plug in 0 for x and 0 for y. And this just becomes 0. That's why I like using zeros. And we get 0 is less than 2, which is also true. So I did these blue arrows, but now we want to look is it has to be where it worked for both. Well, this area right here only had a red arrow. This area in here had no arrows. This area down here only has a blue arrow. This area had both this red arrow and this blue arrow, so that's our solution. So we shade heavy in that area. All of these points, infinite number of points, are a solution. All right, so let's try the next example. Since these are in standard form, I'm going to do x and y intercepts. If you don't like doing x and y intercepts, you can always solve for y and graph it using slope and y-intercept. But I'm one of those, why do more work if I don't have to? So if I plug in 0 for y, that term disappears and I just get x equals 2. So there's my x-intercept. If I plug in 0 for x, I get the opposite of y equals 2, which means y would equal -2. So there's my y-intercept. There's no equal sign, so it's a dashed line. I decided again to check the point 0, 0. I get 0 minus 0 is greater than 2. 0 is greater than 2. That is not true. So I don't want the point 0, 0, so I have to shade the opposite side of the line. So I'm shading below the red line. All right, so the blue line. Again, if I plug in 0 for y, this term disappears. If 2x equals -6, then x equals -3. So there's my x-intercept. If I plug in 0 for x, then this term disappears. So negative 2y equals negative 6, so y equals 3. There's my y-intercept. It has an equal sign, so there's a solid line. I checked the point 0, 0, and got 2 times 0 minus 2 times 0 is less than or equal to negative 6. 0 less than or equal to negative 6 is not true. 0 is bigger than negative 6. So I don't want the point 0, 0, so I have to shade the other side of the blue line. But solutions are only points that work for both. Well, the red shading is down here, the blue shading is up here. There are no points that are in both sets of shading. So unfortunately, we had to go through a whole lot of work to figure out that it's no solution. But we are now done with Unit 4's notes. Yay! One less thing to do.